Hi GCSE Biology, syllabus statement 5.1. Here we're looking at how glasshouses and polythene tunnels increase the yield of crops. First of all, the glasshouse. Glasshouses in some countries known as greenhouses, constructed on a framework like this, simple little house structure. But all surfaces are glass, allowing light to penetrate through to the interior. The polythene tunnels, usually a framework with polythene over the surface like this. The polythene, of course, allows light to penetrate it also to the interior. Associated with things like market gardening. It's also a feature used in less developed countries. It's cheaper than the glass version over here. It's also more adjustable. It can be taken down and replaced much more readily than the glass house. So let's look at how the glass house actually works. So if we reconstruct our glass house here to illustrate the points. Okay, so first of all, we start with solar radiation. And that's our initial source of energy, in the form, of course, of light. The next thing is that, of course, the light is able to penetrate through the glass to the internal surfaces. The next feature, number 3, is that, let's put this down here, the light is absorbed by surfaces inside the glass house. This could be the soil, it could be wooden bench surfaces, whatever's in there, including the plants themselves. The fourth feature is that these surfaces will then re-emit this energy as heat. The heat, number 5, warms the air, raising its average kinetic energy. That is to say, the temperature increases. The 6th point is that the warm air, which is raising the temperature, is trapped. Generally, it would cool at the upper surfaces and then sink to the floor again to be rewarmed by the surfaces within the glass house. How does this cause an increase in crop yield? So we're going here from the warm air in the glass house to an increase in crop yield. Okay, the first thing is to return to the classic graph of the effect of temperature on the rate of reaction, because the higher temperatures in the glass house lead to closer or optimum temperatures for enzyme reactions, including photosynthesis. The second feature is that it provides constant temperatures throughout the growing year, and so we can have constant production. This is particularly true in high altitude areas. The third feature to consider is the prevention of a loss of water vapor. So the crops don't dry out, they have a constant supply of water. That water vapor is not escaping to the atmosphere. A fifth thing to consider is that we're able to avoid frost damage, particularly to seedlings in the springtime. Often with the polythene tunnels having protected the early growth of the seedlings, in springtime these can then be removed to allow full summer growth. A fifth feature, particularly of glasshouses, is that these glasshouses are often warmed by the burning of fossil fuels. This leads to two interesting effects. The first one is an increase in the carbon dioxide levels inside the glasshouse, which means that we have increased the concentration of the substrate for photosynthesis, so we will get more product and more growth. A curious side effect is that inefficient burning of fossil fuels leads to the production of ethene, and this gas turns out to stimulate fruit ripening, particularly in things like the tomato.